Is my screen visible to everyone? Hello?
Yes, I just put thumbs up.
Yeah.
And
Oh,
Ramita
okay.
nodded, and I think Amitabha did too. We just nodded.
Well, I don't see the screen. I just
Okay.
the shared presentation. We don't see it right now. I mean, at least I
Oh,
don't.
I see it.
Oh, you see it?
I do.
Yeah, I can see it too, but
I'm
it's gone.
sharing it again.
Okay.
Is it visible now?
Yes.
Yes.
Okay. So, good afternoon, everyone. I'm Usha Lokala, PhD student at the Institute Computer Science and Computer Engineering Department at University of South Carolina. I'm advised by Dr. Amishet, and we welcome everyone to my proposal today. And we are very thankful to the committee members who joined us remotely and also in person. So Dr. Amishet, Dr. Amitava Das, Dr. Vignesh, and Dr. Marco are from the same A Institute, University of South Carolina. Dr. Raminta, who joined us remotely, she's from College of Health Solutions, Arizona State University. She's a domain expert and she has great experience in epidemiology domain, and we had many collaborations with her. Thank you, Raminta, for joining us today. And Dr. Valerie, she's from Department of Psychology. She's a cognitive scientist, and she's from Wright State University. Thank you, Valerie, for joining us today. So these are the building blocks of my thesis proposal today, and we are going to talk about introducing the research area, and we are going to discuss several scenarios of it. Our technical contributions, the research gaps, and the proposed work and the future research directions. So introducing this topic KOE NLU. So what do I mean by that is knowledge and ontology enhanced natural language understanding. So my proposal title is this approach in the area of computation, social media, and healthcare. So this approach leverages structured knowledge and ontologies to improve the contextual understanding and interpretation in AI systems. It also integrates explicit domain knowledge and relationships between the several concepts identified into the language processing pipeline. And some benefits of this approach would be enhanced contextual awareness, improved accuracy and reasoning, and better alignment with the domain-specific knowledge depending on the context. And some of the applications would be summarization, question answer systems, semantic search, information retrieval, etc. Okay. So these are some of the limitations that we identified in natural language processing: presence of long tail, context, abstraction, personalization, and reasoning. And so we'll see how we solve each of them and how the approach works. Okay. So considering the first limitation, learning the long tail. So if you see this statement, opioids are not legalized for recreation and medical purposes, blah, 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 contributing to opioid overdoses. And we have to answer this question, does fentanyl causes opioid overdose? So it is not possible to understand the statement and the several entities and what's going on inside the statement without the external domain knowledge. So first, you need to understand opioid or class of drugs, and then you need to understand pain relievers are available by prescription, and then you need to understand what is causing opioid overdose. So process of learning long tail would be difficult to support with just natural language processing alone. So contextualization. So if the task is to respond to user like in a chatbot scenario or in a clinical setting, I will like appropriately if they are depressed or suicidal, like that. So it is very important to understand the surrounding concepts or effects or terms related to the depression. So it can be due to several reasons, and common sense knowledge here helps us identify the related context for the concepts in the text. Abstraction in a similar way. Okay, so here, considering sentence 1 and sentence 2, you see entities like benzodiazepine and heightened stimulating serotonin and about withdrawals and stuff. So the task of mapping the low-level features that we identify here to higher-level human understandable abstract concepts is what we call abstraction here. So humans often speak in terms of higher-level abstract concepts, explaining their decisions or communicating their ideas to others. So AI systems need to explain decisions to the end users using abstract domain level concepts constructed from these low level features and with external knowledge. Okay. So coming to personalization. So what we have taken over here is a gender specific depression conversation going on in here. So identifying data point specific information and integrating with external knowledge to construct a personalized knowledge source is what we call personalization in this context. So for example, a person's depressive disorder can be due to family issues or relationship issues or some critical illness or something going on at workplace. So all of these affects the context specific to the individual and especially gender. If you want to treat their symptoms, and medications vary very much differently from gender to gender and than for another person. So personalization is also important. Okay. So coming to the reasoning. So if we observe this text, the improved memory is not dependent on the supplement, and I can take the same dose of naloxone, blah, 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 and there is not much more for it to do. So if we ask this question, is it mental health related or substance use related? So it is more of substance use related than mental health related. But without using domain knowledge here, it's impossible to classify this post either to a substance use related post. And when we ask model why it predicted depression for this text, it is unknown. So. So why we need this approach, KOE-NLU approach? So language models can better understand the context of user queries and provide more accurate and relevant responses if they have like proper contextual understanding, and it helps in reducing ambiguity and to improve the accuracy of the results of language models or any other NLP models. And the model can better understand and interpret specialized terminology, jargon, and concepts. So usually social media data is full of it, full of slang terms, jargon, and it's so unstructured. So it's impossible to understand certain terms without this approach. And it also enables language models to personalize responses based on specific domains, preferences, and individual context. So here comes my thesis statement. A neurosymbolic AI approach using domain-specific ontologies and integrated knowledge graphs can support natural language understanding with semantic reasoning, multi-contextual analysis, and personalization. Yeah, neurosymbolic.
Not neuron symbolic.
Oh, okay, sorry. Sorry for that. So to give a high-level picture of related work in this area, so knowledge augmented models like NoBERT, they embed entities and relationships from KG's knowledge graphs to improve tasks such as question answering. And ontology-based methods, on the other hand, they use semantic role labeling and domain-specific terms for deeper conceptual understanding. So coming to unsupervised techniques like pattern mining or latent semantic analysis, that helps induce ontologies from text, while weakly supervised methods, including bootstrapping and frameworks like Snorkel, they refine and expand ontologies with minimal label data. And coming to the distant unsupervised methods, they automate labeling by aligning text with external knowledge bases. And we have hybrid approaches to combining structured and unstructured data, which uses cross-domain ontologies. All these efforts collectively advance this area by integrating structured and unstructured knowledge in the learning process.
May I ask a question?
Yes.
I'm just curious, and I'm sure this is. I'm just curious. I would have expected that the unsupervised methods are the ones that require the least human effort in general, including for label. But that is not the case in this chart. Can you please explain that?
So unsupervised methods here, they require minimal human labeling effort and minimum feature engineering effort, right? So x-axis and y-axis, if we see.
Yes.
So as you said, they require minimum human labeling
Right.
effort and also
But-
minimum.
And then maybe I should ask you more specifically. So you weekly supervised methods, okay, I would expect to require more effort from humans than unsupervised methods. Why not?
Can you please repeat it again?
Yes, weekly supervised methods, according to your slide,
Mhm.
require less human labeling effort than unsupervised methods. How
Right.
can that be?
So, so weekly supervised methods here in the sense, they're not, they're only partially labeled by humans and not fully labeled by humans. And they maybe use certain label data and train another model to automatically label the unseen data. So still it requires less human labeling effort compared to distantly unsupervised methods. But mostly unsupervised methods and weakly supervised methods, they more or less they come into less human labeling effort.
So
Yeah.
unsupervised methods still require labeling by humans.
Yes.
Thank you.
Usha, I have question. Can I ask now?
Yes, Dr. Das.
Yeah, please go back to the. So I'm just trying to understand. When you say you are trying to use machine learning, are you trying to detect named entity or you are trying to predict their relationship between? So what you are using for this machine learning?
So named entity is just a part of it.
Okay.
So named entity is not the primary objective. It's like part of data processing for us for all the scenarios that we worked on.
Okay.
So named entity recognition doesn't come under the machine learning pipeline or the NLP pipeline here. So we'll see
Okay.
when the architecture comes. Yeah.
No, but then the question is for the ontology building, why machine learning is needed? For the prediction of relationship or what?
So ontology building is different from the ML pipeline. So we constructed ontology, yes, for the named entity recognition primarily. And after that, we identify the relationships and objects of it, instances of the classes we primarily identified in the data. And
Okay.
we use them for entity masking in the pipeline.
And second, just comment, you may, take this or, comment on this later. Most of the citations are quite old. The majority of the papers, year-wise looks very old. But
Yeah,
anyway, you proceed.
I made it purposefully.
Okay,
Yeah, I did it
Please.
purposefully. Yes.
please go on. Yeah.
Yeah.
So Usha, can I just ask one more question? This is related to Marco. My intuitions aren't working here for me. Unsupervised methods still use labels? I don't get that. Maybe I need to fix my mental model.
So unsupervised method doesn't use any label.
Okay,
So the reason why we have weakly supervised methods under that is it is still partially labeled, but there will be we can train automated models to use that already partially labeled small amount of data to generate labels for unseen data. That is one thing we can do. So that's why I have they're interchangeable. Like we can have unsupervised methods down and the weakly supervised methods. So they
that
come
fits-
under the same.
fits my intuitions better, or maybe have them on the same level or something. So, oh, thank you.
Yeah, same level. Yeah. Okay. So this is just to give idea where the knowledge goes in and where the method part goes in. So this is just to introduce the approach in here and to see what are the diverse sources of knowledge we can use towards NLU. So semantic knowledge includes keywords, style, topics, and emotions, while structured knowledge comprise of knowledge graphs, knowledge bases, any database tables or ontologies. So input text here undergoes knowledge representation, transforming it beyond just sequence to sequence models. And methods like large language models or hierarchical networks or graph neural networks or GANs, all these processes knowledge and they come into that NLU box. And finally, this can be applied to several applications, as we know, like chatbots or human information retrieval systems. So why we are using ontology as a knowledge source? So to answer this, we have better semantic understanding. What do you mean by that? So they provide a structured way to define and organize knowledge. You'll see how we constructed the ontology. And ontologies can be tailored to specific domains. So they have domain specificity, so allowing the systems to grasp concepts and terminology in those fields. And next thing is relationship mapping. So by specifying relationships between entities, properties, and concepts, ontologies can help systems infer connections and dependencies, which enhance the ability to interpret our complex statements, as you have seen in the previous slides. And they can, ontologies can evolve and expand over time by continuously updating them with the new knowledge. So yeah, so those are those are the reasons why we use ontology as a knowledge source. Okay, these are the list of the problems we solved. And for this proposal, we are going to talk about the ones highlighted in bold. So the first one is predicting cognitive impairment using process knowledge, and how we built ontology for substance use on social media and dark web, and how we explored the association between drug use and depression, and how this approach can be helpful in understanding mental health symptoms in the multitask learning paradigm. Okay, so what is process knowledge in healthcare? So process knowledge is a learning paradigm that layers clinical process knowledge structures on language model outputs, enabling clinician-guided model of underlying language model predictions. So what do we mean by that? So we have a process going on to predict certain thing in clinical diagnosis, say cognitive decline. So for that, as you know, for depression, clinicians follow a PHQ-9 questionnaire, right? So for example, to predict cognitive decline, clinicians follow certain process like discourse text analysis, MMSE test, MOCA test, and stuff. So, and then they will come to a conclusion depending upon the demographics of that person, depending upon the several test results from those tasks, they'll come to a conclusion of whether that person is at risk or he has a cognitive impairment or not. So that process.
You know, when you say what is process knowledge in healthcare, that will be definition of process knowledge. And what you written is not a definition. You are using it, clinical process knowledge, in something else.
Okay.
So, to change the, you know.
Sure.
It's kind of circular.
Okay. So why do we need process knowledge guided models? So this kind of model, they ensure that language
Usha.
model outputs are aligned with the.
Usha, I have a question.
Yes, yes, Dr. Das.
I don't think I'm quite, understanding the process knowledge concept. You talked about PHQ-9. So in my
Yes.
understanding, whichever limited understanding I have, so it's a very deterministic question answering system, right? You have a very specific question, somebody has to answer in a specific way, and then the answer is, the result is very deterministic. If the answer is this, then yes, this is. So the
Yes.
dynamicity of, in any process which is involved, I don't see it's there. So do you have any other example to illustrate? I mean, what is process knowledge?
Yes. Now I'm about to give the example that we have used in our work. So
Right,
you'll
good.
better understand when I do that. Yeah. So it ensures that language model outputs are aligned with the clinical processes. So integrating clinical process knowledge actually helps in providing actionable insights in real world, and also supports the decision what these language models had made. So it increases like acceptance of these AI-driven insights by healthcare professionals, like promoting collaboration between technology and the clinical expertise. So this kind of model bridges that kind of gap. Okay, so the motivation behind studying this problem and why we use process knowledge to predict cognitive impairment. So discourse evidence shows that use of spoken language discourse analysis is like a sensitive measure to identify early mild cognitive impairment. So we know some cognitive change occurs by age, naturally occurs by age, and many research papers or work in this area, they will help to identify those subtle differences in language production in normal aging versus impairment. So the prevalence of cognitive decline is about 1 in 9 adults, and it is estimated by World Health Organization that this proportion over 60 years of age will nearly double from 12% to 22%. So that is a motivation why we studied this problem. Okay. So what are the research gaps that we identified in the related work of who studied before us this problem is? So existing methods for diagnosing MCI, they require extensive and invasive neuropsychological evaluations such as MMSC, which is mini mental state examination, and MOCA, which is a Montreal Cognitive Assessment. So these traditional methods can be time consuming and not so scalable, resource intensive. So evaluating MOCA test and also a test called MCA itself takes like 40 minutes for each subject, once we have the discourse test and the testing. So it is not easily accessible to all populations, and prior studies have not fully leveraged the potential of raw verbal utterances and the detailed linguistic features possible to extract from spontaneous speech of picture description tasks. So basically, the subjects are asked to describe a picture description task, which I will let you know in the next slide. So they're not much used in the previous works. And also the need for scalability and accessibility for this particular problem is critical, especially in developing regions with limited healthcare resources. Okay, so these are the picture description tasks that I was mentioning. So we call this as a discourse analysis, where the subject is asked to describe what's going on in this picture, cat rescue, and what's going on in this picture, cookie theft. So there are two kinds of analysis that they do for discourse analysis thing. So one is main concept analysis, and one is correlating this discourse analysis and the MOCA test combination. Right now, clinicians are predicting the MCI. So we'll see how we describe this problem. Yeah, so the combination of discourse analysis and MOCA test. So this MOCA test score is actually used to label this subject's MCI for our training data. So there is a score variation between 0 and 30, and we have 3 labels: mild, moderate, and at risk. And we have this label, MOCA score label, as this among these 3 labels, along with the discourse text. So that becomes our training data. So whatever we did with that discourse analysis, we'll see in the next slide. Okay, so the first thing we have done here is to automate all this semantic, lexical fluency and sentiment that we are able to extract from the discourse text. I mean, we have a raw audio speech, and that is converted to text, and we extract all these features from that discourse text. Then we have audio features like acoustic analysis, vocal parameters, and speaking rate from the discourse text. And then we have demographic features like race, education, gender, and income status. So all these features we have used in our training data along with the actual discourse text, and so we trained our models on all comprehensive features, and we are able to extract the utterances, percentage, noun, verb index, proposition density using some formulas we constructed from the features we already extracted. So there are studies that these measures have proven a great role when training the model. They have played a major role in predicting the actual label. So this text is extracted for cat rescue picture, and we automatically extract all these features, and we use Mocha score to label this text, as I said, like mild, moderate, and at risk MCI. So this pipeline, it includes automatic discourse feature extraction. So far what we have talked is like left part of this architecture. Cross-cognitive domain attention mechanism is a technical contribution here. This pipeline predicts the cognitive decline from raw spoken descriptions of subjects in this study. And this study is done in collaboration with Aging Brain Cohort. Arnold School of Public Health is where we got the discourse data from. So the technical contribution over here is CCDA mechanism. It incorporates external knowledge from ConceptNet to enrich these data representations and to leverage some common sense knowledge, basically to mimic the clinician guided model. And it also introduces a new approach to computing this cognitive cross-domain attention for GPT 3.5 model that we have used here, focusing attention head specifically on the relevant main concepts enriched by external knowledge. So what do I mean by the main concepts here? The main concepts that clinicians would like to see when a subject describes this picture description task. So I'll show what are the main concepts looks like in the next slides. Sorry. So these are the results. So for the cat rescue text, we have a Mocha score and the label. So MCI, possible MCI, and healthy. Now we move on to the drug abuse ontology.
A quick question, and
Yeah.
I apologize for it being a little bit off the different track in a sense, but in your slides and use now and also in the slides in the document you sent, these look like really old images, for the narrative discourse test.
Yes,
The one on the right, the
cookie theft.
seems so badly stereotypical, frankly, that I am surprised that this would still be used
Yes,
in a test like this. Are these actually
yes,
pictures
yes,
that
Yep.
come from the?
yes,
Yep.
Actually being used, all our data is based on this.
Okay.
So these tests have been performed. And we have a very large project on campus. The one that our vice president research got from started with money. What is it? Our vice president research.
Julius Fredrickson.
Julius, has this aging cohort, right? This is all the data created over 800 patients.
Yeah, about 800 patients,
patients.
real patients.
Yeah.
So
And
this
those
is
are the data that we got.
this is actually done in combination with the Mocha test. So
So I think it's probably okay for the cohort that we're looking at, but at some point, we're going to have to get out of the 1950s.
Yeah, but the point here is that the team that we work with, that is Julius' team, they actually manually code it even today.
yeah, the
The whole idea was-
students.
It's still,
Automate.
yep, it still is.
So, yeah, and I think results were fairly good, right? in terms
Yes.
of, automation. Manually count how many names, how many things learned. Output.
I'll show you some manually coded sheets too, like when we move forward. So, drug abuse ontology is another thing that we worked on, and we make use of this ontology in several papers that we had, and even several researchers at AI Institute and outside the organization also made use of DAO. So coming to its overview, so this provides an overview of DO ontology. So I just chose cannabis here as an entity. So this is WebAll in representation of cannabis entity in here. And right side, you see the Protege structure of the ontology. So Protege is a popular ontology editor. We used to build ontology as tree of subclasses. So this ontology is designed as catalog of concepts related to substance use. This ontology is primarily built by the domain experts, Dr. Raminta, who joined us here today, and also by Dr. Lamy. Now he's from Mahidol University, Thailand, and he used to be with us when we are working on this. So the ontology was it has classes of substances like cannabinoids and opioids. They were created and populated with subtypes of those substances like morphine, fentanyl, etc. And each substance was defined by its name. And when applicable, information regarding its pharmaceutical name, brand name, slang or street name, and chemical designation are also added to the DAO. So here we see instances in purple. So this is like creating instances of class in a hierarchy, and the instance of a class has its own class and it fills a value. So the instances, that means the instance has its own properties. For example, fentanyl belongs to the class opioid and it has its own properties such as brand name, synonym, slang name. So DAO ontology reuses instances from DBpedia here. So you see the DBpedia column over here. For example, like buprenorphine or cannabis entities over here.
Usha, I have a question about these. Are
Yeah.
they strictly hierarchical? In other words, a tree, or are there graphical relationships so that a child has multiple parents? Because that has to do with ambiguity. So is it like completely a tree?
Yes. So, so when we had that kind of situation, there is no strict rule that this subclass may belong to many classes. So it is not always hierarchical. So one,
Okay,
yeah.
okay.
So this describes how the texts are automatically annotated using the DAO. So we identify here, when you see that piece of text, we identify drug entities, dosage, time interval, route of administration of the drug, such kind of things. And in tasks like lexical, semantic, or syntactic analysis of this kind of textual data, so adding ontology like this works as an external source of knowledge in identifying triples and entities in the data. And conceptualizing the domain in the data acts as like prior requirement for processing, like in data processing step for further information. Next, we are talking about how we evaluated DAO ontology. So it's evaluated in the following semantic web practices, which is called a perfect methodology, perfect ontology methodology. So this provides the following criteria like impact, reusability, design, technical quality, and availability. So the design of ontology is available as graph visualization using web-based tools like WebOwl. And we improved the ontology using those tools, for example, like OOPS ontology pitfall scanner, which automatically detect common pitfalls and provide recommendations to fix them. So this is what do I mean by perfect ontology? So the DAO passed all these levels starting from syntactic validation to ontology consistency. So this just describes the tools that we have just seen. So WebOwl, Triple Checker, and Vapor tool, and the OWL documentation environment. Okay. So now as we have seen how we evaluated and constructed the DAO, so let's see how we used it in understanding mental health symptoms in a multi-task learning scenario. So when we try to understand this framework, here we see a woman describing about her related to a disease condition, which is cardiovascular diseases here. And we have a depression post detected in that kind of conversation. So what do I mean by showing this framework is to identify a research gap. So existing research often neglects the gender-based differences in the expression, especially in the mental health symptoms, especially in the scenario where that social media post is identified with certain disease condition. So it is very complicated. So you have a disease condition here, you have a mental health symptoms here, and you also have a gender-based differences. So there is a lack of this work is done in collaboration with UCSF, University of California, San Francisco Medical School. And we had a proposal together, and this is like a preliminary work for that proposal. So there is a lack of comprehensive studies that simultaneously consider this mental health disorders, particularly in the context of gender-related differences, and challenges remain. So challenges remain in reliably detecting and distinguishing between coexisting mental health symptoms. I mean, if multiple mental health symptoms exist in a single social media post, and previous models do not fully exploit attention mechanisms to contextualize the relationship between MH, mental health symptom, and the gender-based specific language. And there is a gap in developing computational frameworks that can inform this kind of gender-sensitive healthcare intervention based on social media data. So again, I bring that Reddit post here, and this is how we do the entity masking. And the task here over here is explaining gender and mental health prediction. And how is the post expressing depression, anxiety, or PTSD? If so, can we find the gender language here? So that is the task. So we develop a computational approach to understand a gender-based mental health symptom on social media. So our approach here is a knowledge-aware, task-adaptive, Robota-based bioencoder model, which simultaneously identify these symptoms and the underlying gender language. So we developed a multitask learning framework for identifying these mental health symptoms that consider gender language fused in a health condition related post. So this is the first study in the cardiovascular disease domain that considers the gender language in mental health related post. And to justify the variations in the gender language description of symptoms, we propose a gender encoder, gender enabled mental health framework, as we call here GEM methodology. And the performance of GEM is improved for the task of symptom identification along with the task of gender identification in a multitask learning scenario. And we compute the attention over the two encodings for generating a mental health context-aware representation of gender language.
Just a quick question. If you go back to the previous slide.
Yes, Dr. Das.
Yeah, it's a dot product, right? ES and EG, and dividing by the dimension of the vectors. Then again, why are you multiplying again with EIG? The softmax,
You're asking about that attention formula.
right? Exactly.
So what is the question again?
The question is, you are
Can you
doing a
please-
dot product between these two vectors. Fine. You are dividing by the dimension of the vector. That is also fine. Why again you are
Yeah.
multiplying with EIG?
So to generate to give that attention mechanism a gender language touch. I mean, I want to generate a mental health aware, context aware general language encoding. So
So you are
that's
getting
why.
two attention from the symptom encoder and gender encoder, which is your EIG and
Yes.
SIG. You are doing a dot product.
Yes. ES
Again,
is for symptom and EIG is for gender.
right. So you got the dot product and divide by the dimension. Fine.
Yeah.
Why again multiplication?
So we have tried just for the softmax of cross product of generative gender and the symptom. But when we cross product, I mean, that is the query key and value scenario. When we did the cross product with the gender thing, then that worked better when we implemented the models.
Okay, not clear. Okay, move on.
Okay. Sure. So these are the results and the comparisons with the state-of-art models, and what is the actual label for it, and what are GEM methodology predicted for each post. Okay. So the technical contribution for this work is the GEM framework and a bioencoded model that separately encodes symptom and gender text, and attention mechanism that creates mental health aware representation of gender language. By integrating gender embeddings with word embeddings and applying the multi-head attention mechanism, the model becomes capable of focusing on gender-specific language patterns, which enhances the performance. Yeah, and automatic labeling and expert validation. So this also, this is the main, the data set is the main, also the main contribution for this work. So
No,
now we are moving on.
So Usha, I have a quick question. No number to report here. What are the numbers? What is the accuracy level?
Yes, I can do that
No,
in my another.
if you remember.
Sure.
Otherwise, okay.
I
Go on.
don't remember.
No
Yeah,
issues.
I
Go on.
don't remember. Yeah. So let's move on to how we applied DAO to understand cannabis and synthetic cannabinoid use. So these are several things that we have done on this semi-automated platform, like analyzing characteristics of marijuana concentrate users and identify factors associated with daily use of concentrates. And among these, we chose to do the studying the cannabis association with depression for this proposal. But these are the other works that have been done in this research area. Okay. So now here, as you can see, the entity locator module, this uses drug abuse ontology to map input words in a tweet to their corresponding entities in the ontology. And the process involves computing the edit distance between entity names from the DAO and n-grams in the tweet. So the identified entities are then masked to its root word. For example, the terms related to cannabis are all masked as cannabis, and the terms related to depression are masked as depression. So this is the framework to identify the association between cannabis use and depression. So we use the gated K-BERT framework. So it consists of 3 main modules. First one, the entity locator module, which we already seen in the previous slide. And the next one is the entity position aware module and the encoding module. So these modules work together to identify entities related to cannabis and depression in tweets and to extract the relationships between entities. So coming to the entity position aware module, this module infuses knowledge of entity positions into the model to better capture the contextual information here. So it consists of 3 different layers again: position embedding layer, convolution layer, and entity position aware attention layer. I'm not going details of these layers in the interest of time, but yeah. And then we have encoding module, which aims to obtain a comprehensive representation of tweet by leveraging both BET language model and the CNN-based position aware module. And the pre-trained BET model provides contextual representation of tweet, and the gated feature fusion model, which is a technical contribution of this work, it combines the features from BERT and the position aware module effectively, which we call a gated fusion mechanism here. And this mechanism learns like an optimal way to join these features. And overall, the gated K-BERT framework effectively combines domain-specific knowledge with advanced techniques to extract meaningful relationships from social media data, providing insights on how we can classify cannabis association with depression in terms of treating, healing, and ambiguous or So we have 4 labels. Let me. Yeah. So to predict these labels, reason, effect, addiction, and ambiguous. So we trained our model on the manually annotated high quality data set in this work. And these are the examples of each of these relationships, reason, effect, and addiction, and ambiguous. And it is very challenging to label this data set as well. And the data set is also released to the open research community for further research. Okay. So I'll just quickly go through some of the work that we have done in the area of addiction. So we have crawled 3 crypto markets manually using custom web crawlers, which is very challenging to crawl from the dark web. The market names are Dream, Market, Tosca, and Wall Street. And they were periodically crawled, maybe for 2 years or so. And we analyzed social media data from active opioid users to understand what are the behaviors associated with opioid usage. Over 70,000 opioid-related listings are collected from the dark web. And those raw HTML files that we have collected, they were parsed and processed to further extract the substance names, product weight, price of the product, shipment information, as you can see here. And we collected about 300K opioid-related posts from 6 subreddits using the terms that we have identified from the dark web. So that is pretty challenging. So one of the works we have done is detecting substance use on social media, which is a reflection of dark web that we call on social media. And the model used here is knowledge and time-aware analysis. So when opioid-related listings are crawled from crypto markets, social media data is also collected from the subreddits and Twitter using a curated lexicon that we derived from DAO, Drug Abuse Ontology. And word-based methods are used to generate sentiment and emotion labels for these social media posts. So the sentiment and emotion vectors are then passed through a bidirectional LSTM with an attention mechanism to capture the historical context of each post to identify the post relevance. So we have done it at a post level, which we consider its emotion factor, sentiment factor, and also the history of that user for that post. And the framework integrates these historical sentiment and emotion features with the current post encoding to predict whether a post indicates substance use disorder or not. And this is the end-to-end system of that. So when we zoom the last module, the last box, knowledge-aware time series analysis. So when we zoom that box, this is the architecture of that thing. So we developed a knowledge-aware bird-based models to perform sentiment and emotion analysis, integrating historical sentiment and historical emotion context. Then we take the temporal features and historical context into the learning process to predict substance use disorder. And we have the encoding representing the sentiment and emotion spectrum. So sequential models such as RNNs and LSTMs are apt ways to encode these kind of representations due to a sequential nature of social media posts too. And at the end, we predict if substance use disorder is present or absent. Okay, we have done some error analysis where it is it becomes so complicated in the post and comment. So we analyze the sources of errors and discuss the predictions made by our model here. So if you see the post 1, examining this post where multiple drug coexist along with emotion associated with other drugs. So for example, mixing depressants and stimulants or mixing medications with opioids, our model is not able to do well here. For example, when substance A might not often co-occur with substance B in the historical post of this particular post. And another scenario is post-level ambiguity, which is always there. And the next thing is sarcasm detection here. So even if it doesn't contain any clear substance use disorder present or absent in the third post, with a history of ambiguous post present difficulty in identifying substance use disorder, which makes it a very interesting natural language understanding problem, combining sarcasm detection with the this post and how can we predict the present or absence of substance disorder. Those are some examples. Okay, so these are the takeaways from today's presentation. How does knowledge help in epidemiology domain like this, and what are the knowledge sources we have used in our work, and what are the social media sources, and yeah, and what is the real impact that we have made. Okay, so this is going to be the proposed work, which is main concept analysis for the rest of my program. So to introduce this concept, main concept analysis. So it is a discourse assessment that measures informativeness of a discourse sample. And MCA is a hybrid discourse measure that provides some information on micro and macro linguistic features. And it also has shown good sensitivity in differentiating between healthy controls and individuals with community disorders like mild cognitive impairment. So this MCA test is jointly done along with the discourse text analysis. It is mostly related to the discourse text analysis, and I'll show how. Okay, so the main concept analysis involves coding the discourse text analysis manually. What do you mean by that? So the end output of the coding would be AC, IC, AI, and II. The first part of the coding, A and I, starts for accurate or inaccurate, and the next part of the coding, C and I, stands for complete and incomplete. So, and there is another coding like absent. If main concept is not produced at all, then it is absent. Main concept in the sense, I'll give examples of what do I mean by the main concept in here. So I'm just trying to explain the flow chart in here. So when we extract a main concept from the discourse transcript, if the main concept is not produced at all, we code it as absent. If all the essential elements are present, then we check for accuracy, if it is accurate or not. So for checking accuracy, there are other conditions to check if it is accurate or not, which we'll see in a moment. And if one or more essential elements are produced, then we'll check for if all essential elements are accurate or one or more essential elements are omitted. So this is a clinical process that they're doing to come to a calculation. So what they do at the end, they take the codings for each main concept and they put it in a formula to calculate a score. So I don't have the formula in here, but that's what they do.
Sorry, I'm just
And we are
asking,
trying to,
Usha, just
yeah.
a quick clarification. This MCA you are proposing, or this is already existing, you are making a computational version of it. What is your stand?
Yeah. So main concept analysis is a procedure that they do manually,
It
all this
already
coding.
exists. It
Yeah,
already
this
exists.
exists.
Okay,
Yes,
you are making
yes.
a computational version of it.
Yes.
Okay, okay. I'm good. Go on. Yeah.
Yeah. So this is how a manual main concept analysis coding looks like. So for cat rescue.
It is because of, in our case, not only data set, but ground truth, meaning what those coders do today is available to us. So you can compare with that.
Yeah. And these are the problems that they actually wanted to solve. So these are the problems presented by the ABC cohort before us to work on. So yeah. So manual MCA coding is, this is how it looks like. This is for the cat rescue picture. So on the right side, you can see the main concepts and the alternative responses allowed for each main concept. So for example, the little girl was riding her bicycle. You can look for any alternate responses like she, the girl, the child, or any girl's name. She's riding a bicycle. So for instead of was riding, you can see rode rides, was on, is playing. So this is a very interesting natural language problem to solve. And this is how the manual coding looks like. And they come up with totals of number of ACs, ICs, AI they found, and they put everything in a formula to come with a score for each subject. So this is a real participant test over here. Okay. So as I said, they follow certain rules for accuracy and completeness, and each of them individually is an LP problem here to solve. The first one, accuracy, when to determine if it is accurate or not, they check for wording, grammatical form, articulation, and if they find inaccurate words, inaccurate main concept, And when they restate the same information again and again, they, as a human, they will summarize, even if they restate the same information, they'll say, okay, this candidate had already mentioned this main concept. So things like that. And that is a criteria for completeness. Missing essential information. If all of the essential information in main concept is not mentioned, we can consider it incomplete.
Usha,
Yeah.
I have a question just to follow on this.
Mhm.
Does this testing take into account cultural backgrounds and, language fluency of the people who are completing those tests, and how that, if that would be the case, how you would deal with that, or eventually, well, maybe that's too much to ask, but just out of curiosity, do they take that into account, those issues that people can be from different cultural backgrounds?
Yes, Raminta. So this particular test may not take into account the cultural or demographic things, but the previous work that I mentioned, the predicting cognitive impairment work, that takes all of the things that you mentioned into account to predict cognitive decline, and age is one of the major factor that highly correlates with the prediction. So yeah, but this particular test acts as a supplemental information like other tests like MOCA or MMSC. But this one is complicated to actually automate the process. Does that answer your question, Raminta?
Yeah, thank you.
Yeah. Okay. So this is how the coding looks like in the coding guidelines in short. And these are all the publications and tutorials and invited talks that we have given or worked on. And the ones highlighted in red, pointers in red here, are chosen for this proposal. So the dissertation timeline, we just submitted the mild cognitive impairment paper in June. And I'll be working on the main concept analysis paper in August, and working on the manuscript writing and submission. So that dissertation would be around November. So this is an overview of my research. What are the methods we used and what are the application areas and the proposals that I got funded from, and what I did for outreach in terms of education and training, in terms of tutorials and invited talks. So these are the contributions to the research community. And these are the proposals that I worked on in detailed titles over here and the domains they come from. And yeah, thank you. And I'm open to questions.